All right, welcome to this explainer. We've all grown up hearing the exact same old saying, right? Seeing is believing. It's supposed to be the ultimate baseline for truth. If you see it with your own two eyes, it just has to be real. Well, today we are going to completely challenge that assumption.
Because, is seeing really believing? Or is your brain just kind of taking you for a ride? Today, we're taking our own brains for an interactive test drive to prove that visual perception actually isn't some perfect window into an objective reality. It's really just a constructed guess. Think about it. Your brain is essentially locked inside a dark room, receiving electrical signals and desperately trying to piece together a coherent picture of the outside world. And as we'll see, it makes some pretty wild mistakes along the way.
Okay, to kick things off, let's just look at the sheer scale of the machinery we're dealing with here. It is absolutely wild to think about, but neuroscientists estimate that roughly 50% of our entire brain is involved in visual processing. Literally half of your brain's computing power is dedicated just to figuring out what is right in front of you. And when light hits your eyes, those signals don't just go to one neat little vision center. Oh no, they are dispersed to more than 30 specialized areas. We're talking dedicated zones for processing color, tracking motion, calculating depth, and identifying form. All of this info gets combined in a flash. Yet despite all this immense biological processing power, our brains still make massive, totally predictable errors. Which brings us to part 1, faking depth and perspective. Let's explore how easily your brain's understanding of space can be completely hijacked. Just take a close look at Schroeder's staircase. It perfectly exposes our brain's total obsession with 3D space. You look at it, and boom, you immediately see steps going down from right to left. But if you flip it upside down, it suddenly looks like it's going left to right. Why? Because your brain automatically grabs those flat shadows on a 2D image and desperately tries to force them into a 3D perspective it already knows. Your brain sees a shadow, just assumes depth, and builds a staircase out of thin air. You know, playing tricks on human perception actually has a really long history. We can trace a straight line of clever optical tricks from German scientist Heinrich Schroeder's 2D shadows way back in 1858, all the way to Steve Simpson's spotting patterns on a cafe wall in the 1970s, right up to modern mind-bending masterpieces by Japanese mathematician Kokichi Sugihara today. In fact, in 2020, Sugihara took this concept to a whole new level and won the Best Illusion of the Year. He took a flat, printed 2D image, shaded it, glued it to a basic 3D structure, and flipped it at a 100-degree angle. The result is just impossible. An object placed at the top of these physical stairs suddenly looks like it's resting at the bottom. As Sugihara himself points out, we're literally witnessing the way our brain tricks us into perceiving unreal things. It proves depth itself is just an illusion. Moving right along to part 2, confusing lines and shapes. Let's see how your brain handles something as simple as basic counting. Take a really close look here. Count the bars for me. How many do you actually see? This famous internet test leaves people completely baffled. Some folks will swear up and down they can count 11 bars, while most tap out around 7 or 8 before their eyes just start to cross. Well, reality check. There are actually only 6 complete bars. If you trace them from the top down, the upper bars are perfectly real, but the 7th and 8th? They're completely incomplete. They are deliberate traps, designed entirely to blur your vision. Because your brain expects a continuous pattern, it frantically tries to fill in the blanks, literally multiplying the shapes in your confused mind. Next up, check out this classic pattern. Focus on the dark blue lines running horizontally. Are they perfectly parallel, or do they look crooked and slanted to you? This is the famous cafe wall illusion, named after Steve Simpson, who noticed this exact trick on a wall in Bristol over 50 years ago. They look incredibly slanted, right? But here's the crazy part. If you blur the image, the illusion totally fades, proving they are in fact perfectly parallel, straight lines. Your visual processing is just getting tripped up by those tiny black and white bricks sitting right at the intersections. Throw in some curved elements inside the blue lines, and the effect is so strong it completely hijacks your ability to see a straight line. All right. On to part 3, tricking color and light. Let's see what happens with a famous grid that will literally make you see things that aren't there. So, look at this black grid with the white crisscrossing lines. If you focus your attention dead center on a single intersection, you'll clearly see a pure white dot. But the second you let your eyes wander around the grid, dark gray and black dots will immediately start popping up and dancing all over your peripheral vision.
This is the classic Hermann grid, also known as a simultaneous light contrast illusion. You perceive a dot as white for a split second, and almost immediately your brain overrides it and tells you it's black. It's a brilliant demonstration of a vital principle of human perception. We absolutely do not always see things for what they really are.
Biologically speaking, this all comes down to the retinal cells in your eyes. When one of these light receptor cells gets illuminated, it fires up, but in doing so, it actually blocks its neighboring cells from firing. Because the intersections of the grid have more light than the lines themselves, the dots at those intersections get heavily inhibited by all that surrounding light. Basically, your own biology is physically forcing you to see dark gray spots that just do not exist.
And finally, Part 4, creating fake motion. For our grand finale, we're combining motion and color replacement into what's known as the Pac-Man Chaser. I want you to stare directly at the central cross right now for about 5 seconds. Just keep your eyes locked right on the center. If you do this, you're probably going to see a green disc appear out of thin air, running in a circle, aggressively chasing those moving lilac spheres. Well, I promise you, absolutely nothing in that image is actually moving. Not a single pixel is shifting its location. You're just experiencing the phi phenomenon. This happens when completely stationary objects, placed side by side, are flashed rapidly one after the other. Your brain hates choppy visual data, so it just stitches those flashing objects together to create a smooth, fake illusion of movement.
And what about that green disk? That's an afterimage. As the original lilac sphere disappears, your brain desperately tries to fill the void with its complementary color, which happens to be green. Honestly, if we change those spheres to blue, your brain would instantly start painting a yellow disk for you instead. It's wild.
As the renowned Japanese psychologist Akiyoshi Kitaoka points out when analyzing color illusions, what we're really observing here is our own brain desperately changing its guesses about reality in real time. Color itself is just an illusion, created inside our visual systems. Our eyes perceive wavelengths, but our brains paint the picture. You are quite literally watching your brain work, guess, fail, and then guess again.
Which leaves us with a pretty wild question to wrap up this explainer. If neuroscientists are right, and 50% of your immense brain power is dedicated to vision, yet that massive biological supercomputer gets fooled so easily by basic lines, printed shadows, and flashing dots, how much of the world you see around you right now is absolute reality, and how much is just a well-constructed illusion? Thanks for hanging out with us, and definitely keep questioning what you see.